Okay, this is HRW92P045, or number 6 on your homework, called 1D motion number 2. So we're looking at this one. We've got a ball thrown vertically from the ground level to rise to a maximum height of, your number will be different, so I'm going to just put H max is 40, like that. I want to know the maximum speed, the speed that it left the ground, and I want to know how long it was in the air. And we'll talk about the graphs later. So 40, make this full screen. Okay, so let's call the maximum height H. And for me, that's 40 meters. Yours will be different. So A, I want to know what velocity what velocity it left the ground with. Okay, so I'm looking for V0. That's what I want. I don't know what it is. Okay, so I'm gonna do that standard thing that I always make you do, which is your initial position, your position at time t, your initial velocity, your velocity at time t, your acceleration, and t. And we fill in what we know. I'm gonna assume we're starting the ground. I'm gonna go to a maximum height of 40, so that will be my position at time t. This is what I want to know. I want to know what velocity started with. At the maximum height, the velocity should be 0, so that's what that is. And for gravity, or for acceleration, we use gravity, negative 9.8 meters per second squared. I don't know t yet. T is actually going to be what I'm solving for on part B, but we'll get to that. So the equation I want to use, I don't have t yet, so I need something with distance in it, but not time. The only one that does that is this guy. V squared equals V naught squared plus 2a change in position. Okay. I want V naught squared, not V, so I'm going to solve for that, and that's not too bad. That is, let's see, if I move this to that side and this to that side, I get negative V naught squared on this side, and I get sorry, this is getting really squished. Minus V squared over there. So I'm going to leave that negative there just because, well, it annoys me. I'm going to put some zeros in first because that'll make things a little bit easier. For instance, V is 0, so this is gone. That's gone. Y naught is 0, that's gone too. So what I really have is negative V naught squared equals 2a times y, which is h. So I'm going to move the negative to the other side just to make it a little bit easier and plug in the numbers. So V naught squared is negative 2 times negative 9.8. I'm going to leave this stuff out for a little bit, and y is 40. Leaving the units out just because I like to be annoying. Okay, put that into a calculator, and I get 784. But that's still squared, so I gotta square root both sides to get the velocity. Put that in a calculator, and I get the initial velocity was 20. Oh, I forgot already. It was 28. Sorry about the jumping around. Alright, let's see if that was the answer. Yep, that is the answer on my numbers. Your numbers may be different. B asks, how long will it be in the air? So I'm going to go back to my math, and that means I want t. However, we won't be done. Even when we find t, we won't quite be done, but I definitely need it. So let's find it. So t is what I want now. I also know this now, so I can add that to my list of things I know. When I find this t, it will be giving me the time it takes to get to the top of its height, the highest point. But that's a good starting point, so let's go. Now that I know, well, pretty much everything except for t, any equation is going to work. So I'm going to use the easiest one. I'm going to use this one. That's the easiest one. Why not use it? Just go for it. All right, solve that for t, and I get v minus v naught over a. So v is 0. V naught is 28. meters per second, and over A is 9.8. And when you pop that in a calculator, we are going to get 2.86 seconds. That's rounded, by the way. Just check that, 2.86. Notice this is not going to be the right answer because it's 5.71. What we have to do is, that was just the time from when it started on the ground all the way to the top, right there. I also need to include the time it takes to get to the bottom. Now luckily, this is symmetrical, so if it takes 2.86 seconds to get to the top, it'll take 2.86 seconds to get to the bottom as well, for a total time of 2.86 times 2. Just go ahead and times 2 over here on my calculator. 5.71, which is what I have for the answer over here. All right, lastly, let's just talk about the graphs. It says, which of these graphs is that of y versus t? Well, I know that y goes up and down again, but not at a constant velocity, so it's not going to be a straight line. The only two that go up and down again are A and D, but D is all straight lines, which is no good, so it's got to be A, and in fact it is. Which of these is that of V versus T? Well, I know the velocity started out going up, which is positive, and then it pauses at the top, and then it comes back down with a negative velocity, so I should have something that starts off positive, passes 0, and ends up negative. The only one that does that is E, so it has to be E. And finally, acceleration. Well, the acceleration the whole way was gravity, so it's a constant negative 9.8 meters per second squared, sorry. And the only one that does that is H, which is why it is H. I hope that helps. If you have any more questions, email me or message me on WebAssign.